We are looking at sections 3.6 and 3.7, where we will be dividing, as well as using synthetic division to find roots, and then writing polynomials when given certain roots. So we can see in these first couple ones here, we're just simply dividing. Make sure that when we are dividing that your denominator is going into all terms. All right, so this first one, we only have one term on top and bottom, so it doesn't really matter. But the second term, students sometimes forget this, that this 3x is going into both of the terms in the numerator. Simplify where you can. And then in 3, if you want to during class, I can show you how to do this in your calculator, where you can put this function into the y equals, and then you can evaluate at each of these x values. And so here we get a -2 and we get a +8. We don't really concern about the values, and you see these points. If we have a negative y value and a positive y value, we see that this is what the intermediate value theorem is discussing, is that we must pass through the x axis at some point there. And so we can use your calculator to approximate that. And I can show you this during class. Here, you're either going to be giving the k or the 0. In this case, it's -1, or the factor. So if we're given the factor of x plus 1, the k is -1. So we set that equal to 0 to find our k. Our k is what goes into this box for synthetic division. And then each of these values comes from the coefficient of the function. So 1 is the coefficient of x third, 5 is the coefficient of x squared, 9 is the coefficient of x, and 5 is our final term. If we are missing any of these, it is replaced with a 0. So we must have each of these place values so that we can use synthetic division. First step is to bring down that first value, which is 1. Then we multiply here. That gives us -1. And then we combine these terms. 5 minus 1 is 4. And then we continue. So -1 times 4 is -4. Combine these values to get 5. Multiply, we get -5. We combine, we get 0. So whenever we get 0 as a remainder, that means that whatever this k value was, that is indeed a 0. So we know that the function goes through the x-axis at x equal to -1. And then in writing the quotient, since we started with x to the third and we're dividing by x, our leading term is going to be 1 less. So 3 was it before, now it's 2. And my coefficient is 1. My coefficient for the next term is 4 and 5. Continuing this, we're given a factor, so my k is 4. Here, we do not end up with 0 as a remainder, so we have to write it like so. So 7 will go over whatever we are dividing by. It was x minus 4 as a factor. Here, we're given a factor of x minus 3, so my k is 3 is what goes in here. We use the process as before. We do end up with a 0, and we write it out as was. Here, we're dividing like so. My k is -4. Here, I am missing a term here. So it starts with x to the third power. I don't have anything squared, so I must put a 0 there. I do have a remainder of -7. And I just put -7 over what I divided by, x plus 4. Here, it's asking if -4 is a 0, so -4 is what goes in here. I evaluate, I see that this must be a 0. It is not, therefore it is not a 0. Here we're trying to find other zeros. So in doing so, we use the given zeros. We have -1 here. We go through our process. I get a 0 here, so I know I must get that. When we're given a 0, we know we must end up with a 0 here. If not, then you know you've made a mistake. So now I have what is left here, my quotient. So I have x squared minus 12x plus 35. I can factor this. There I am. And so since it's asking for other zeros, I set these equal to 0. So I know my other zeros are 7 and 5. Here I know that -3 is a 0, so I use that to simplify. Here I cannot factor this, therefore I must use the quadratic formula. Here's my a, b, and c values. Math happens, and there are my other two zeros. 1 plus square root of 13 over 6, and 1 minus square root of 13 over 6. Here I know that one of my zeros is 1. So I use that, I get 0 there, so I know I did that correctly. And then I factor. And so it says factor completely. So you're already given one of the factors. Since I know that k is equal to 1, one of my factors is x minus 1. The other two that I found are 2x minus 1 and x plus 8. Here, once again, we're looking for it to be factored completely. I use the given 0 to help reduce it. So I get 2x squared minus 7x plus 6. I can factor that. Just don't forget your original factor. So x plus 5 was given to me, and then I figured out 2x minus 3 times x minus 2. Here we're using imaginary zeros, and so we must keep in mind that when we do end up with an imaginary number, we have both its positive and negative of this. So since you're given and it says, oh, you have zeros 1 and 6i, it also means you have negative 6i. And we have two examples of where we have to do this. And so here it says our leading coefficient is equal to 1. So that is where this 1 comes from. And then I had to set up the given zeros as factors. And so I have x minus 1, x minus 6i, and x plus 6i. And so we have to do some foiling. And so I use this one first. So we have x squared minus 6i, or sorry, plus 6xi minus 6xi minus 36i squared. That reduces to x squared plus 36. And then I have to FOIL again to end up here. Here we have to look for our value of a. Up there it told us our leading coefficient was 1, so we have to find this value. So we're given all of our zeros here is negative 3, negative 1, and 4. So that means my factors are plus 3, plus 1, and minus 4. I am told that when I plug in x as negative 2, my y value is 18. So that's where this 18 comes from, and this is where this negative 2 comes from. I use this to solve and find out what my a value is. Now I go back over here. I know that this a value is now 3. And then I use the given factors once again, and I just simply multiply and distribute to find out my p of x. We're going to do the same process here, except we have some imaginary numbers here for our zeros. And so we're given that it is 4. Since I have 1 plus I also have 1 minus I. And so here we're doing the same thing. Here we're trying to find out what our a value is. When I plug in positive 2, I get a positive 20. So all my x values are replaced with 2. And as you see here, I have minus 4. And I distribute the negative here. So minus on the outside of 1 plus I gives me negative 1 minus I. And then if I distribute the negative here, I get negative 1 plus I. We solve here. We have to FOIL here. So we end up with a is equal to negative 5. So that's what happens here. And then we have to make sure we collect like terms when we are foiling. A lot of tedious work here. Just make sure you keep it straight. And then our last step is to distribute that negative 5. Here we're looking at multiplicity rules here. And so our rules here, when we have an odd exponent, that means that the function is going to go through that 0. And if we have an even exponent, that means that we're going to bounce off that 0 at that x value. And so here I see I have x minus 2 to the first power, so I know that that is going to go through at 2. And I have x plus 2 to the third power, that is odd, so I know I'm also going to go through at negative 2. And I can see that happens here in this function. I go through negative 2 and I come back through. Also looking here, I have, we're looking at end behavior like we did on the last section. So I have an even leading coefficient or exponent, and therefore I know I should be going up on both sides, because this one also does what it needs to, but it's going down on both sides. So that's why we choose this one. Here I have going through at negative 1/2. I am going through at positive 2, and then I am bouncing off at negative 1. So I could see I kind of bounce at negative 1. I come up and go back down through negative 2, and I come back up through positive 2. Once again, my leading exponent is an even number. Therefore, I should be going up on both sides. And our last problem here, more of the same here. We need to find out what our a value is. I'm looking at my x is 0, my y is 70. And here are each of my factors, x plus 4, x minus 5, and x minus 7. I solve to find out my a value, which is 1/2. I don't have to multiply this all out. It wants it in factored form, so I just have 1/2 and then times my factors.